Good morning, everybody. My name is Terrell Boyer. I'm coming to you from Lake Dallas, Texas. Today I'm going to put together a video, and it's going to be a fairly quick video because I wanted to show you one of the strategies that I use in troubleshooting SIP audio. It's fairly straightforward, but I did a quick check on YouTube and I didn't really see any other videos explaining this, so thought I'd take the opportunity to share it with you. Today what we're going to be looking at is a capture between a normal, just a SIP endpoint, so an IP phone, and an SBC, a session border controller. And the key thing that I'm going to show you here is, so I've done a lot of videos in the past on troubleshooting audio and how to identify one-way audio. But this video is going to go more along the lines of how to start to resolve one-way audio issues. So the first piece that you want to know is you've got two devices here that are having to communicate at a minimal. You have your IP endpoint, and then you have the session border controller or the PBX or the SIP provider or something on the other end that's going to be setting up the other side of this conversation. So in the SIP negotiation, when the call first starts, one of the things that you're going to see is an invite message from the server to the client, and then you'll see a response message from the client back to the server. Well, as part of this exchange, there's a special packet in there called the SDP packet. What the SDP packet is going to show you is the negotiation of the audio ports. So there's some key information in there that I want to pick apart for you guys. But I think the first thing we need to do is make a test call. So these are just my IP phone keep alive messages. We're going to go ahead and hit a restart there. And then I'm going to hit redial on my phone here. We're just going to make a quick call.
Thanks for choosing American Airlines. Your call may be recorded.
Okay. So we just did a quick call to American Airlines. So we have everything we need in this trace at this point. So the key thing to look at here is these packets that are labeled SDP. So you'll notice here, this is my IP phone IP address here. So the initial call left, so my source IP address left from my IP phone and was destined for the SBC at this IP address. Excuse me. So in that original invite message, you'll notice it says SDP here. So let's go ahead and open up the packet and take a look at that SDP packet. So if we go down here in the bottom, go under Session Initiation Protocol. We're going to go Message Body and then Session Description Protocol. So this is going to be the information all about the audio stream, which comes in really handy when you're troubleshooting audio because a lot of one-way audio issues, they're very simple to resolve if you know what's supposed to happen in the first place. These packets are the first thing to tell you this is what's supposed to happen. So what's being told here is in this information is that, and this packet will get modified as it goes out, towards the closer to the source or the server side of the conversation. But the key things that I look at in this particular packet are the media port. So it's saying communicate back with me on port 20,052. It's also saying connection information. Communicate back with me on 73.130, 192.168.73.130. So the two key pieces of information that I understand here are that the IP phone device is expecting that the audio will be returned on this IP address or returned to this IP address on this port. This is the port that the IP phone is expecting the audio on, and it's UDP 20,052. If the phone doesn't get the audio on that particular IP address, on that particular port number, then it's not going to play audio. Okay, so let's keep looking down here. Those are the key things that I wanted to cover today, or just these two bits of information. So the next thing though, so now we know what the IP phone is expecting. Now we need to go and find a packet from the server and see what the server's saying. So here we are. This is the first SDP packet. So let's go look at the next SDP packet. So this is 66. So this is sourcing from the server on the other end. So now we're going to look at the same packet. and that it's saying communicate back with me on this IP address. And let's see if the port number's here. Yep, 40,046. So basically, the server has now instructed the phone, okay, I understand what you're saying, but now I need you to communicate back with me at this IP address. And this IP address isn't always going to be the same as the control protocols, basically, the SIP messaging, signaling side. That's the word I'm looking for. Well, I'm out of practice. Haven't done a video in a while. So anyways, this IP address could be different than the actual IP address, or this one rather, right here, the connection address. This IP address could be something completely different than the signaling address. So even if this said 202 here and this said 201, that means that whatever's on that end is expecting the audio on a different IP address and this port number. So now we know. Let's go ahead and let's just bring up a notepad here real quick and kind of map out what we know so far. We know we have a device at 192.168.73.130, and it's expecting audio on, let's go back and look at that SDP packet, 20,052. Okay, so let's go here, 20052. And then we have the other IP address here, which is 66.226.209.201, and it's expecting audio on, you guys can beat me to it, 40,046. Okay, so this is all on the signaling side of the conversation. So this is just the two devices negotiating, saying, okay, these are the port numbers that we need to set up our audio stream on. So if you remember with an IP phone, typically an IP phone sits behind a firewall and it reaches out to the server. So it's always going to go to the server's going to go back. And depending on which SDP packet is first is who initiates the call. If this was an incoming call, then you might see that the source address was the actual server coming toward the phone. Now, one thing that's of interest here is we have yet one more SIP packet, but we only have two people in the conversation, so let's see what this is. What we have here is this is sourcing from the SBC destined to the IP phone. Okay, so it's still saying 66.226.209.201 and port 40,046. Okay, so it didn't really update any information. This is just another confirmation that the IP of what IP address they're expecting the traffic on. So one thing that you may see, and this is something important to watch out for, and I got a Wireshark trace the other day and I was able to cut through it pretty fast, because one of the things that I saw was the SDP packet, this port number changed, and immediately after that what I started seeing is destination port unavailable. And what was happening is one side of the conversation was changing the port, but the other side of the conversation wasn't updating their port information, and it was still sending information to the old IP address. And you were easily able to tell, okay, as soon as that port changed, it was after a hold and then a resume. Basically, after that port change, then it didn't update on both sides, so now we're sending traffic to a port that's not expecting it. So then natural response is to come back destination unavailable or port unavailable, right? So that's the easy thing here. So now I know these two devices are expecting audio on these two port numbers and these two IP addresses. Now let's confirm that, and we're going to go type in a new filter here, udp.port. And we'll use just one side of the conversation, 40,046. If I can type this morning. Okay, so we have our filter in. And so the two ports that we expected to be communicating on are 20,052 and 40,046. So you can see this is the RTP stream now going back and forth on those two port numbers that I just told you about. So this is the other side. So SIP is always two sides of the conversation. You have the signaling side and you have the audio side. Now we're looking at the audio side of the conversation, and it's right there where we expected it to be on those ports. So where this comes in really, really handy is as the packets traverse the network and go through routers and application layer gateways and SBCs, these port numbers have the ability to get modified. But at the end of the day, if you go to the two endpoints, one on either side, you go to the IP phone on the far side and go to the server on the other side, if that audio doesn't get back to the original port that it expected it on, it's not going to play the audio. So just a key thing to keep in mind. I wanted to share that. I've done a lot of videos on how to identify one-way audio, but not really how to troubleshoot and to figure out exactly where that audio should be in a real-world scenario. I'm sure you guys have seen my other videos, but now you can go in, once you've identified RTP traffic and the G711 protocol, you can go into telephony, go to RTP stream analysis, and go to player, decode, and then here we are. Here's our conversation that we can play back.
Thanks for choosing American Airlines. Your call may be recorded and...
Okay, and you see here, again, this is the 20,052 talking to the 40,046. This is the 40,046 talking to the 20,052. All right, guys, that concludes my video today. That's the lesson that I wanted to share. I've seen a lot of interest in SIP over the last year or so since I started putting videos out. So these are fairly easy videos for me to knock out and do fairly regularly. So I'm going to try to do some of these. And then if you saw my website at tcbjunior.com, you'll see the latest update that I'm switching more into a Wi-Fi role as a technical professional. So I'm going to start doing some videos along with Wi-Fi. So I'd be interested in your feedback, you guys that are out there doing SIP and find this video valuable. Leave me a comment and let me know if you'd also find Wi-Fi content, Wi-Fi troubleshooting valuable as well. All right, guys, thank you for your time today. Have a good day.